So this is inside Laravel. This is a stream about getting to know Laravel from the source code. So the goal here is just to help you better understand your tools. I believe that knowing your tools makes you better at using them. This is not about how to use Laravel. Yeah, no kidding. Glad you caught the stream early, but not 80% in. Yeah. Yeah, this is not a stream about how to use Laravel, how to build stuff in Laravel. It's about how Laravel itself is built. Today we're going to be covering the service container specifically. So the main two things I want to cover is binding, which is I think what most people interact with the service container directly are doing. And then the second part is resolving, which is the bit that Laravel does based on those bindings to inject stuff into your code. So for those of you who are not familiar with the service container or dependency injection as a whole, so the service container is an implementation of dependency injection. And what dependency injection allows you to do is to automatically resolve things that are required by the code that you write without explicitly coupling them. And what it means is that you can replace things. So an example where you might want to do this is, for example, your storage. So you might be using local disk for storage, but that's probably not a good idea in any sort of scale environment. If you have more than one server, using the local disk is bad because obviously those files are not shared by both or multiple servers. So you might want to use some sort of cloud provider, some sort of shared resource. So that could be Amazon S3, it could be DigitalOcean Spaces, I think they're called. It could be Google Cloud Storage, or whatever the Azure equivalent of that is. And you, as a person who is writing code, particularly if you're writing a library, or you're writing code that's going to be deployed by many people in many different environments, you might not necessarily want to hard-code a dependency on, say, Amazon S3 when someone else who is using it might want to use Google Cloud, for example. So that's kind of where dependency injection really comes into its own, is this idea of being able to create dependencies between functionality instead of between implementation. So your code depends on functionality, not on implementation. So that's what we're going to do today. Is we're going to jump into the service container. So let's take a look here. I'm just looking at the docs. Here's a simple example. Yes, perfect. So here's a constructor. It takes an Apple Music object, and when you tell Laravel to create an instance of this class, which happens to be a controller, but actually it doesn't matter. Laravel can do this for any method that it executes or any class that it creates. It will look at the arguments for the method, in this case construct, and see if it has some way to automatically create those. So let's get a look here. So I thought where we would start is we would start with binding. And the reason I want to do that is because we're actually going to use this kind of to dig into the code. So typically you're going to do binding in some sort of service provider. So I'm going to just use the app service provider because it exists by default. And we would do that in the register function, or the register method, sorry. I'm just trying to find the example of that here in the, I think it's linked, service providers. Here we go. Okay. Yeah, okay. So, there are multiple ways to bind stuff into the container. You can bind instances or you can bind singletons. And so The main difference here, I'm actually not sure what the difference is, and this is something we're going to discover, what the difference is between bind and instance. And I think the difference is going to be this one just takes an instance of a class that you've already instantiated, whereas the bind will take a closure that will create an instance. And so with instance, you would only get one copy, so it's almost a singleton at that point. Whereas with bind, you would get a new one every time. So let's go ahead and take our thing here, and we're going to do this app bind, and then I guess we need some sort of class. Let's see what we have in here. Let's just create a service class. So directory services, new PHP class, test service, and we'll do example service. Okay. All right, so we have a class. Great. And we're going to create a constructor. I love that comment. Thank you. And in here, we're going to have to take something else. So let's create a, let's make this the dependency into a controller. I want it to be a controller. We'll just create a second service. It's fine. So new PHP class, parent service. Okay. And in here, we will also put a constructor, and we want to take an example service. Perfect. Okay. All right. So in here, we are going to bind the example service, and to create that, we are going to return a new example service, and then in here, we can do parent service function. Let's do it like that. And I'm going to make this one a singleton, just so we kind of have an example of both. So yeah, let's start digging into what exactly these do. So this is the container interface. So there will be an implementation of this. That is the Illuminate container. And let's take a look here. So the very first thing we're going to do is we're going to drop the stale instances. So I'm assuming that it, just unsets either instances or aliases that have the class name. And to be clear, like, this is just a string. It isn't actually required to be a class name, and I think that they are moving towards making class names the norm. I know there was a change in facades, I think specifically, where you used to be able to just return a string, and then they made it so you would return the class name. I would always use the class name pretty much, especially as they now have bind if, or not now, but they have bind if, so maybe that's an option for sort of differentiating which one you get back. But yeah, so the first thing we're going to do is we're going to drop those instances, and we'll get into exactly what these two mean later. So let's go back to bind. And then let's see here. If no concrete type was given, we will simply set the concrete type to the abstract type. After that, the concrete type to be registered as shared without being forced to state their classes in both of the parameters. Okay, so if you don't specify anything in concrete, then it will set concrete to the abstract. So my expectation then is if I do this and nothing more, all we're saying is that we want to resolve this through the container, and it will just create a new instance of example class and will inject whatever it needs to. So in actual fact, we can, I believe, do that instead here. And let's say maybe we take something in here. Let's just take the profile controller because we have it. Not sure why you would do that, but it's fine. If the factory is not a closure, so that's the concrete, it means it is just a class name which is bound into this container to the abstract type, and we will just wrap it up inside its own closure to give us more convenience when extending. Okay, so if we don't pass in a closure and we don't pass in a string, so that's important. You can't pass in anything else. It'll throw a type error. Otherwise, it will create a closure. So really what this is doing is just simplifying the logic down here. This could, like, we could get rid of this and do something like yeah, like it could literally just be that. The only problem is that then we have to, so like we could do that, right? If we wanted to simplify that, not simplify, but like remove that change. We don't need to do that, so let's undo that. All right. Let's jump into get closure. So what this is going to do is it's a closure that takes the container and any additional parameters, which you can also put in here. So this closure here is taking the container, and we can type in that, right? So there we go. And then it uses the abstract and the concrete, which could be the same. Not sure why that's not a triple equals. I'm a big favor of using the more strict comparisons. It could, no, those have to be, like, abstract has to be a string. So this is also a string. Yeah, why is that not triple equals? All right, that's fine. So if they are the same thing, which means we're just building an instance of the object, we're going to call, what was that function? Sorry. Bind, get closure, build. Okay, so let's take a look at the build method. Remember that container is going to be the container class. So we're just kind of in the same thing here. Let's sort these alphabetically. Okay, so build does not exist in here. Ah, there it is, build. Okay, cool. If the concrete type is actually a closure, we will just execute it and hand back the result of the function, which allows functions to be used as resolvers for more fine-tuned resolution of these objects. Okay, so we're not in that case right now, right? So based on what we were, I'm going to split this so we can kind of see two copies of it. Nope, minimize that. So we were in bind. Get closure. Okay, so this is where we're at. We're in this build here. So we're just passing in the string because that's what got passed in here. So we know that this is not going to apply. We'll come back to that then. Otherwise, it's going to use reflection. Okay, so this is what I was expecting. So the reflection API, for those who aren't familiar with it, is a way to programmatically inspect the code at runtime. So what we're doing here is we're creating a reflection class instance of the string. So in our case, that would be example service. And there could be an exception, which it catches, which is nice. If it's not instanceable, okay. Why would it not? Okay, so if you're trying to register an abstract, whether that's an interface or an abstract class, I think it could also be an enum. I'm not sure if reflection class works on enums. Let's give that a quick shot. Let's find that out. New directory enums, new PHP class, test enum. Oh, nice, it automatically chose enum. Case, yeah, sure, that's fine. Oh, we need to string, okay. And I need to really quickly kill Docker stop. Oop, sail stop. Sorry, I'm just killing sail in another project. Okay. Now we can come back over here and go to inside Laravel sail up -d, and we're going to jump into Tinker and new reflection class. Copy reference class. Oops. And what was that function? It's instantiable. Okay. Yeah, that's what I was expecting. So, mainly what I wasn't sure of was whether or not you could even use enums with reflection class, because they're technically classes, but not really classes. But I did expect that to work. Okay, so if it were an enum, we'd be going into here. If it was an interface or an abstract class, we would be going into this not instantiable, but that is not the case here. So we're going to add our concrete. Again, this is a string to the build stack. And let's see if we can figure out what that is. Let's just pull that up over here. Build stack. Okay, the stack of concretion is currently being built. So this is going to be part of how it resolves recursively. So it'll be interesting to see how that plays out. So we're going to get the constructor. If there isn't one, there are no dependencies. That's pretty smart. So that's a nice way to sort of short circuit that. So if the constructor is null, we pop it off the build stack because there are no dependencies, which means no recursion. It fires the after resolving attribute callbacks, and then it returns the instance. Now, how do we get that instance? Oh, here we go. Instance equals new concrete. That is, I'm not a fan of the way this, like just the code style, doing the assignment in the argument, but that's fine. So yeah, we just create an instance, super easy. Personally, I would always, like, that would have made it more obvious to me, but like that's fine. So that is the end of that. Now, if there is a constructor, then we're going to get parameters. So we can take a look at this. So let's go back to the source code, new reflection class. And we are using our example service. Get constructor, is that what it was? Okay, so here's our constructor. And then we can get parameters. So if you're not familiar with reflection, so this is how it works. So we get the constructor. So this is a reflection method, has a name, the class, and then the parameters are a public method here. Are they public? Might not be public. Let's actually find out. Parameters. Yeah, I didn't think so. So they must be private or protected. But ultimately, we can get them using get parameters, and that will return an array of reflection parameters. Those also have a name. They tell you what order they're in, and any type hints that are associated with them. You can also, for example, get type, I believe. No. Oh, how did we lose that? Oh, right, because I did this. Sorry. We can also get the type, and then that means that we can also get the name. for example. Nice thing about that is it does mean that we can see if it's nullable. Allows null, maybe. Yep. And whether or not it's built in. So is built in would be the native types, right? So string, integer, etc. You can't tell that from just the type hint. The other thing that is possible is we can see like union types, for example. So let's actually add a union type in here, or user, which, like, again, this is not great, but I just want to kind of show what that looks like. So, oops, Control C. Let's run that again. So there's our constructor, get parameters, get type. Sorry, let's look at get parameters first. So we can see, like, this is now a string. So we'd have to parse that by hand. Whereas if we look at reflection parameter and get type on it, we actually get an array of types. So now it's a reflection union type, whereas before it was just a reflection named type. And reflection union type then is an array of reflection name types. So we get to see for the whole union if it allows null. And then we have the subtypes within that, right? So I think probably get types on that, yeah. So that is pretty great. So let's go back, we'll undo that change because I hate that even more than putting the controller in there. And then what we're going to do is, based on those parameters, we're going to resolve the dependencies. So this is kind of where the magic happens. What's interesting about this, I think, is that right now this is just about creating objects, but there is also the ability to call, I think it's app call, which will just do dependency injection on any callable. I believe it's any callable. So yeah, let's take a look at the resolution of dependencies. So this just takes an array of reflection parameters. So for each of those, if the dependency has an override for this particular build, we will use that instead of the value. Otherwise, we will continue with this run of resolutions and let reflection attempt to determine the result. Okay, so let's take a look at this. I'm not sure if this is contextual binding. I suspect that might be closer to here based on that. Or it might be because it was actually passed in. And so that's the bit that I expected it. So just as an example, going back to my app service provider, where we're calling app make here, we could pass in, I don't know what the argument is. What is it? Profile controller? Okay. So we could pass in profile controller, new profile controller, right? So that is an override in this particular instantiation. So let's check and see. So has parameter override. Okay. Okay, so array key exists, dependency name, so that's going to be, in this case, as we saw over here, profile controller, right? Get last parameter override. Okay, so interesting. So with is a stack, and this is going to be set. Is the only place? Yeah, here. Now that's interesting. When did that? We didn't get here, did we? We were in build. So we're in here. Were we in build? We started out in bind. And we were in get closure, which was calling build. Yeah. Okay. So this makes sense. Okay. So in the case of a string abstract, which it always is, and a string concrete, which is optional and would default to that, we would call build. But this is getting called by the service container. It's getting called by resolution. And so parameters here only comes into play when we resolve it. So that is interesting. It looks like if we bind this way and then attempt to make that, it's not going to take any parameters. I'd love to test that. Yeah, let's see if we can make that happen. Let's try to xdebug this. Go back to my terminal. We have to quit this. And then okay, that's already in here. Oh, I hate this. All right, 1 second. Oh, not that. Where is servers at? There we go. Localhost. Okay, apply. Okay. And then we do PHP IDE config equals. Now this gets tricky because we're inside of the container, so we need to actually do this now. So PHP IDE config equals server name equals localhost. Now we can do PHP artisan tank. And let's see. Okay, now we have source. Great. So we're right here. We're just getting the closure right now. That means the break should have been inside the closure. Let's try that again. Okay. Oh, interesting. Why are we resolving this right now? Did I... Oh, we're not resolving this. Okay, that's fine. We're just resolving anything right now. So let's just let this all run through. This could take a hot minute. What I need to do is put... Oh, yeah, no, I just need the whole thing to go through. Okay. Okay, so we should be... Yep, perfect. So now what I want to do is I'm going to try to create an instance of my example service. No, this should have been registered. Oh, and this has already happened, so I'm not really sure this is going to work, but let's find out. Class, and then it's profile controller. New app HTTP controllers profile controller. So if I'm right about this, parameters essentially gets lost. So we got the parameters, but because we're dropping into build and we're not taking any parameters here, then by the time we get to, so we're gonna get down to here, and there is a constructor, so we should be here. We'll get the parameters, but it's always going to so we want to be here. This might actually be a bug. The closure and bind. No, it is past container. Application, I believe, actually just kind of is container. It's sometimes a little weird, but we'll look into that. Anyways, okay, so has parameter override. So we were in here, and we were actually inside of here. So unless this with, it does. Okay. So here's our instance of the profile controller. So that is how that happens. How did that get populated is what I want to know. Because I actually didn't see that happen. I guess we can step up here. So we called make, which calls resolve. And then we saw that here. This is where with is set. Okay, so not a bug. Not surprisingly, not a bug, but just not something I was expecting. So hang on, how did we get here in our code without going through that? Oh, we were in the binding, right? Not in the resolution. So that's what happened there. Okay. So, oh wait, hold on. This must have been gone through originally, though, because if we look at bind, so it does a build during get closure. Yeah. Whether we want it or not. That's interesting. Well, no, that's not true. This is just returning the closure. Oh, we dug into code that doesn't get executed yet. That's all that happens. Alright, not a problem. Alright, let's go back to here. So we've just got a closure, and it then binds that closure. What is happening here? So, compact. What is shared? Shared false. Okay. So it's just going to create an array of concrete, which is our closure, it's always a closure, right? So it's either a closure from this, or we created a closure, and shared, which is just the shared that's passed in here. I actually don't know what shared is for. If the abstract type was already resolved in the container, we'll fire the rebound listener so that any objects which have already gotten resolved can have their copy of the object updated via the listener callbacks. I didn't know that was a thing. I'd love to know what that is. Let's take a quick search of the docs for that. Oh, it's rebound, not rebound. Rebinding. The rebinding method allows you to listen for when a service is rebound to the container, meaning it is registered again or overwritten after its initial binding. This can be useful when you need to update dependencies or modify behavior each time a specific binding is updated. I suspect that it's not quite what we were seeing there, is it? Because this is the get rebound callbacks. That's just this thing. I guess what that allows you to do is, like in here, let's say your podcast publisher had some sort of underlying dependency. You could have a setter on the podcast publisher. Oh, sorry, that's the class being bound. But let's say there was something else that depended on podcast publisher. You could have a setter on it, I guess, and set that. I've never had a use for that. If anybody else has, I guess let me know. Not where I want to be. Here's where I want to be. Okay. Okay. We're still in the container. We are going to... Okay, so here we are. So that is how we get binding stuff in there. So to be clear, just to double, run through that. First of all, we drop any stale instances. So if it was already resolved, we're going to drop those. If we only passed in one argument, or at least because with named arguments, I guess you could do abstract and then shared. But if we don't pass in concrete, then it will set concrete to the abstract, making it a string. If it is not a closure, then and is a string, we will go ahead and get a closure, which just builds the or resolves whatever is passed in. So in this case, this would get called by the resolver, which would already have bound any parameters in. So in our case here, where we're calling this make, will add this to with inside of our container, such that build can pop those off the stack. It is interesting to me, and I'm curious if why parameters isn't just passed through. Honestly, I don't know why this stack exists. Maybe we'll find out later, though. Okay, so that's we're not going to dig any more into the resolution right now. That is binding. Let's get rid of that. Why is that complaining? Stop. What? Did I break the class by accident? Yes. Okay. Alright, so going back to our app service provider, so we now know what happens if it is passed in and if it's not. Shared is just stored right now in the service container. Application extends container. Right, okay, so that's why you can always type in container. But, okay, yep, cool. Alright, so singleton. Let's take a look at this, because this is slightly different. I don't expect actually a huge amount of difference here. So singleton just binds, but sets shared to true automatically. So those are basically the same thing. Yeah, this just defaults to shared equals false. So that's all that shared does. That feels anticlimactic, if I'm being honest. And it will have all the same, string, nulls, etc. Stuff. Okay. So ultimately, what that means is that we can do bind and pass in true here, and that is exactly the same. All right. Is there anything else on the binding side of things that we want? So, just take a look here. This is going to be like a lot of this is it's under binding, but actually it's just about resolution. Maybe contextual binding would be interesting to look into. So let's take a look at that. This app, when the parent service class needs the example service class, give, and then we can drop this in. Okay, so we're gonna, I don't know if we have to bind it for contextual binding. I don't think so. As far as I'm aware, Laravel's autoloader will take care of that. But I could be wrong. Let's take that out of here. All right, so let's take a look at what's happening here. So when, oops. Okay, so this is where aliases come into play. Util array wrap concrete as C. Okay, so it can be, oh, that's nice. So this could be an array of classes. So that's a pretty handy utility. So for each one of those, if it is indeed an array, we're gonna call. Sorry, not sure what happened there. Not array wrap. I want to get alias. Let's just bring this over here now. Okay, so if is set this alias is abstract, so if it's already in there, then wait. This is a local array, not this aliases. Okay. So if there is an alias, oh, it's actually it's a recursive, right? So let's just see. Aliases, is that not a thing? How do we get aliases? Nope, not what I wanted. That was annoying. Okay, we'll figure out where aliases come from. Alright, so basically it's going to loop through a recursive set of aliases until it gets to the original that isn't an alias. Okay, that's fine. And then it has this contextual binding builder. Okay. So that takes the container and all of the aliases. Does it get... Sorry, is that... It's only returning a single string, right? So ultimately it's going to resolve all the way down to whatever the original type name is. I'm not sure. Ah, right, and you can pass multiples in. That's right. Okay. Okay, so this would be the, I don't know, it actually shouldn't be called aliases. That's misleading. And it shouldn't be called get alias. It should be called get original. And, okay, fine. Contextual binding builder. Okay, so it takes the service container and the list of aliases, which are now called concrete, which is better, and just sets those, which means that this actually could be protected. And I wonder, is there there's no. I'm surprised there isn't a refactor for that in PHP Storm, but anyways, okay, so doesn't do much. And then we have the needs, right? Okay, so that was the next part in our call, right? So needs, that just gets set, returns this, so it's just a fluid interface. And then the next thing was give. So it will wrap the list of concrete, which I'm pretty sure it can be a string, it says here, but I guess there may be other places to call it. But if there's not, it's always an array anyways. We add the contextual binding to the container. Okay, so now we have contextual. So previously, when we bound stuff in, it got put into bindings. And now it's going into contextual. So this is the concrete. Okay, so this is the name of the thing being resolved. This is the thing it needs, and then we have the implementation there. So that's the function, right? The closure. We're also going to resolve that abstract, so the thing that's needed, to its concrete here. So it's just a multi-dimensional array, right? Of closures, presumably. Or strings. Okay, so you can also pass in just like a class name. That's fine. So what that means then, this is public, right? So it means in theory, this like call could also be expressed as what was it? Add contextual binding, right? So could also be parent service class, example service class, and then our closure. So these are functionally identical. I prefer this one, and obviously that's why it's there. I suspect this is kind of just around for legacy, but there we go. Okay, so I think that's the end of that's the end of our contextual binding stuff. So all we've done then is inside of our container is we have bound some stuff into bindings, some stuff into contextual. Yep. What we haven't looked at is instances, and we haven't looked up, we haven't done resolution yet, right? I think what's going to be interesting is ultimately resolution is going to end up with stuff being put in there. That's my suspicion. I really wish there was a some sort of note that told me which function these calls were in. That would be so much more useful than a line number. Is that possible? Whoa, there we go. That's cool. Okay. PHP Storm is amazing. I know a lot of people like Visual Studio Code and things like that, but PHP Storm continues to amaze me. I could literally get rid of, I'm sure, the file name Oh, that's nice. So this is like read and writes. And we can turn off the self references. That is cool. Okay. And, oh my word. It gets better. Okay, cool. So the one that we actually probably care about is one of these three. Probably this one here. Yeah, in Resolve. If it's shared. Okay, interesting. So, so that's how that's going to work. All right, so as we know, as we said, the other way to add stuff is this instance, right? So I can do parent service class, new parent service, new example service, new profile controller, right? This is terrible, but like that will add it into, and is there other arguments? No. That will add it to the instances method, and I'm pretty sure it doesn't do anything except just add it to that array. Removes the abstract alias. We'll take a look into that in a moment. Test whether or not it's bound, but ultimately, it also removes it from the aliases, which we still haven't really gotten to. Alias a type to a different name. I can't say I expected it to be anything different. I was just kind of hoping that it would give me a reason why. That is interesting. So aliases and abstract aliases are sort of the same thing. Or based around the same data, like they're going to be built up at the same time. I suspect the difference is that this one ultimately is going to be, like we saw here, like we're unsetting aliases, but we weren't unsetting that other one. So, but here's the remove abstract aliases. So that's to do with that as well. So if it's not in the aliases, so it hasn't been aliased at all, we do nothing. That's simple. One moment. Has been aliased. We know those are being set at the same time. Then it also checks the abstract aliases for each aliases as index. So let's go back to where that was set. So this is okay, so they're inverses of each other, right? So an alias can only go to one abstract, but an abstract can have multiple aliases. All right, that is what we're doing here. So let's go back to remove abstract aliases. All right, so if it's never been aliased, then there are no abstracts that it could be aliased to, I guess. Otherwise, we're going to go through all of the abstract aliases. This feels very heavy. I don't ever use aliases, and I don't know if they're kind of implicitly registered. If you're using aliases, let me know. But I've never really had a reason to use them, so I'm not sure if they're performant or not. But this doesn't feel like it's necessarily performant. And again, this is just adding instances to the container, right? So, and that happens every time we resolve a singleton initially. So potentially that gets really, really, like there's going to be a lot of times this is going to be called. That again, assuming there is an alias, right? If there is no alias, then it's pretty quick. But as soon as you add an alias, we've now got a for each over every single abstract alias, and I feel like that's the bit that's tripping me up here. Let me just split this to the right. I want to go back to that alias function. Yeah, so this is the alias that is being searched for. Whereas here we're looking for abstracts that are associated with that alias. And that is an array, just an indexed array. And we need the index because we're going to unset it. Okay, so I'm not sure, honestly, I don't know why we're removing any of the aliases to start with. But also, like, why is it not... Oh, interesting, okay. What's happening here? Oh, okay, to check if it was rebound, okay. Or to fire the rebound. Okay, so... we'll remove all of the references from the abstracts to the alias. So if you have an alias that is alias to class A and class B, for class B and class A it will remove that alias. Then it checks to see if it has been bound previously. It removes the alias, and then it sets instances and fires the rebound. I understand what the code is doing. I don't understand why it is doing it. That is where I'm getting tripped up here. Essentially, once you create an instance of an abstract, you can no longer alias to that same name. I'm kind of being very particular about that because abstract can be a string and it could be anything, right? So let's say that you just had an abstract called storage and you wanted to alias that to file system and directories or something. I don't know what that would be. As soon as you register an instance for storage, all of those aliases get blown away, right? Which means they no longer work. They would no longer resolve, which is problematic, maybe? I don't know how it would fall back in that case, right? But again, I don't really understand where aliases are being used and whatnot. So, all right, we'll continue from here. That was instance. Was there anything else? I do kind of want to register some aliases and just check this out, right? So, this app alias. Let's say. And I'm actually going to put. I'm going to put this in twice. Okay, so now we've got it in twice. And then what we want to do is this app instance. Yeah, like that, right? I'm just going to copy these and I need to import the example. That's fine. Did I leave that xdebug? I did not. Thank you. What I need to do, though, is inside of instance, which is probably already executed, so I'm actually going to have to kill out of that. Try again. Alright. Alright, that's what I expected, is that it's going to run probably a whole bunch of times. Get rid of that. And that. Those are not helping. Okay, so we're now here. And what I want to do is paste. Oopsie. Okay. Yes, that was a mistake. So this needs to be app. And then we're just going to copy this and use it. Okay, and then I can now copy. Alright, so let's see here. And now we should get the debug statement, right? So, okay, perfect. So if I actually try to make an instance of it right now using the alias, we do get an example service, right? That's fine. Let's go through and do that and then run it again. I still get an example service. Even though the aliases got removed? It is still in there. But we unset it here. Oh, no, we unset the abstract. So if the name of the abstract is used as an alias, it can no longer be used as an alias. That's what is happening there. So I would have to register an instance using like example service. So real quick, let's do that. App instance example service. Okay, so now if I call this, we get an example. That's fine. I'm actually not going to know. So at this point, actually, it shouldn't work. Yeah, that's okay. That's what I expected. So, okay, so it breaks the alias. That is, I think, reasonable behavior. But also could be unexpected. I think it's very worthwhile noting that that is something that happens when you register an instance in the container with the same name as an alias. The alias no longer functions. Which means, like, because there's no type checking, you could put anything into that. So, like, right now, presumably if I re-register that alias, it will continue to do the thing. So, if I were to put in, instead of an example service, let's do, like, new user, right? So, I think right now, oops, I should have done that already. Yeah, so right now we're getting the example service, which I would absolutely expect. Now we will no longer, I don't think. Oh no, we're still getting it. Did I? No? Okay. Should that be? Shouldn't that not be the error? But like, now we've done that. It should be a user. Now it's a user. That's what I expected. There's no type safety if you're using aliases and instances for the same thing. I think that's very worthwhile noting. I believe the reason that the make worked is because I'm not entirely sure, honestly. Maybe because it was already registered as an instance, but it wasn't shared, so it shouldn't be. Alright, we'll stop there on that. But that is, I think the big takeaway there is to be careful with aliases. And I think that's possibly the reason, or maybe contributed to the reason why facades no longer use aliases. Which is essentially what they were using, right? Just a string. Okay, let's get into resolution. So we're going to get into make. So I guess there are several ways to resolve. So there's make, which could also be the resolve function. Pretty sure that is just an alias. Yeah, app. Oh, okay, and the app function is just a resolution to make. Okay, yeah. Ultimately, it all comes down to the container make method, right? Which calls resolve. So hang on. Resolve calls make, which calls a function called resolve. I mean, I guess it's friendlier, but it is what it is. All right, so if we want to resolve an alias, we know this will just give us the concrete back. So in our example earlier, this example service, which was alias, would return back the example service class name. We'll throw our callbacks and then get contextual concrete. So this is the other side of the contextual stuff. So first of all, is there a contextual binding? Which is a very simple thing here. So hang on. See, this is this whole stack thing again, right? So if you remember, we did have the build stack that's getting created during the resolution, and the point of that is allowing recursive dependencies. So it's using that to figure out what we're trying to resolve. So if contextual, the thing we're trying to resolve, abstract, which is what? Sorry. Okay. Let's go back to where this was called resolve. So abstract is the thing we're asking for. Okay. Or null. And that's a very simple, like not much to that, right? Okay, so going back to here. Next we would see if the contextual binding might be bound under an alias of the given abstract type. You need to check if any alias exists with this type, and then spin through them and check for contextual binding on these. All right, so if we found the contextual binding, we return it here. Otherwise, we need to check and make sure that there are no abstracts which have aliases. All right, so in that case, if we were to pass in example service, but we had the contextual binding on the example service class name, so we pass in this string rather than the class name, this would be null and so would not return, but this would not be empty. And ultimately, it would go through them and look for until it finds example service. And if it does find one, then it will return it. Yes. Yeah, okay. Yeah, it would look until it found the string that we had passed in that was the alias. And if it finds a contextual binding for that, then it will mark that. So I think I have that backwards. Sorry. If you put the contextual binding on the alias, it will find it for the abstract that you're passing into. So, okay, so back to resolve. If it needs contextual binding, that happens. Okay, so if it returned a contextual binding, or there are parameters. So if there are no parameters, if it's not empty. Yeah. Oh, so interesting. So when you pass in parameters to resolve or make or whatever, that essentially implies a contextual build, which makes a ton of sense. I really like that they're reusing that kind of same logic there. If an instance of the type is currently being managed as a singleton, we'll just return an existing instance instead of instantiating new instances, so the developer can keep the same object's instance every time. Okay, so if you have a singleton or an instance registered in the container, that presumably is, so a singleton that's been resolved, or an instance you've registered explicitly, and it doesn't need contextual binding, so you're not, or contextual building, sorry. So you're not passing in additional parameters, or you're not doing it in a context where contextual building is a thing. So you haven't registered it using a contextual binding, right? Then it will just return the instance, which makes a ton of sense. Otherwise, if it adds the parameters, which could be empty, right? So you could have no parameters, but you have a contextual binding from here. So this could just be null, but it's a stack. So we need to add it anyways. Sorry, it could be an empty array, not null probably. Yeah, empty array. But so we need to add it to the stack. And then if concrete is null, so we've got parameters, which means it's contextual, but we don't have a contextual binding added here. Here actually really is where we want to be focusing. Then it will do a get concrete. So let's take a look at this. If we don't have a registered resolver or concrete for the type, we'll just assume each type is a concrete name and we'll attempt to resolve it as is, since the container should be able to resolve concretes automatically. So if is set bindings abstract, return bindings abstract concrete. Okay, so we saw this earlier when we were doing the binding, right? There was here. So concrete is this closure that we created, or the closure that was passed in, right? So essentially it's getting whatever the builder is. So whatever, either the closure that was automatically created because we just passed in a string and no concrete to bind. Is it concrete? Yeah. So we didn't pass in concrete to bind, or it is presumably. Sorry, where are we now? Here. Oh, we lost our place, didn't we? Here. Yep. Okay. Okay, so it's either going to return a closure or the string, the abstract, right? That's how I read that. Yeah, if it's not already bound. Okay, so that means if you are trying to resolve something that was not added to the container explicitly, then it just returns the class name. And then we have this is buildable. All right, so that's going to take concrete, which again is either that closure or the abstract, it takes the abstract itself. So let's take a look here. Is buildable. If the concrete equals the abstract, then it would be true, or if it's a closure. Okay. And then we have build versus make, right? So we already looked a little bit at build, but let's take a look at this more. So this takes the concrete, which again could be the string name or the closure. If concrete type is actually a closure, we will just execute it and hand back the results of the function, which allows functions to be used as resolvers for more fine-tuned resolution of these objects. Okay, so create the build stack, and into that we're going to add an SPL object hash of the closure. Okay, and then we return so return, calls the closure. Okay, yep. So if we looked at this, right, it just returns the end of the array for with, which was created during resolve, where we added the parameters. So it just calls the closure, passing in the container and whatever parameters were passed to resolve. And then it pops it off the stack if it was able to complete that. And I suspect a couple things are going to happen here. One is if it tries to recursively create itself, well, why are we not really honestly, it's probably because of error stuff, right? So you'll notice there's a try finally here, not a try catch. So if this fails in some way, it's not going to be pushed off the stack, which means that we can then examine that stack to see what was attempting to be executed, right? To resolve whatever this thing is. If it's not a closure, then we go into the reflection class, concrete, check whether it's instantiable. So this, I think, is what we were looking at earlier, right? So we already went through all of this. Yeah, we already looked at all of this. If it has no arguments, then it just creates it. I'm not sure how I feel about this. I suspect this will fail. I mean, it will fail if you have like a private constructor. Whereas if this were instead new instance, then I believe that can be executed without caring about the privacy stuff, like whether it's private, protected, whatnot. But we probably don't want that, right? It's private for a reason. So, yeah, that's fine. All right, so we've now looked into build. Let's take a look at make. So, to be clear, this is happening if it's a string or it's a closure. If it's neither of those things, then the question is, what is it, right? So, I think it's going to be that contextual thing, right? So resolve. We're back to resolve, actually. So that's recursion, right? Oh, yeah, I'm looking for it, but it's right here. Alright, so if it's not a string or a closure, or it doesn't, or if they're not the same, then it will just recursively make. Trying to figure out how you end up in a situation where concrete and abstract are strings but aren't the same. So we called abstract. It's based on this, right? So, and we decided that that was ultimately, it's going to return the binding, which is either a closure, a string, an array, or null. Oh, okay. Yeah, alright, that makes sense. Okay. So that's resolve. And now I kind of wanted to just last thing here is I wanted to look at call, I think it is, which is the other. Well, no, there was one other. Let's take a look at how. Well, no, this actually flows into what I'm talking about. So. Mainly what we looked at right now is object instantiation, right? So when we want to create a new instance of an object, and dependency injection happens, and that's on the constructor, but dependency injection happens in other places in the framework. Specifically what I'm thinking about is handler functions in jobs, right? So if we go ahead and create a job, sure, whatever, we can have dependency injection here. No, we can't. And the reason for that is this gets called during dispatch, right? So let's just say like user, right? So we want a user in here. And then down here, where we want to handle this, we want our example service, right? This is where dependency injection happens, is on the handle function, not during construct. And what will actually happen is static pending dispatch. Yep. When dispatch is called, it will create an instance of the test job and pass in the argument to dispatch. Right? These are just forwarded to the constructor, which means there's no dependency injection happening. Or maybe there is in addition to that. I actually don't know the answer to that. Let's try it, right? So let's do, what is it? Parent service, right? Yeah, okay. Let's take a quick look at that. So, genuinely don't know if it is. Yeah, too few arguments. Oh, sorry, I've broken my make here, haven't I? My app. Service provider, app, service provider. Yeah. Okay, let's try that again. Okay. So, app, jobs, test job, dispatch, new user, and that's all we're going to pass in. I don't know that that's going to create an instance of it. Let me... Where does that come from? Sorry. Test job. Oh, okay, it's this one, right? Yeah, okay. So let's add an xdebug break here. This is not going to work because we're not in the container. So, oops, let's do that. Sail bash. Okay, so we're now here. Yeah, see, here it's just doing new static, which means it's not doing any dependency resolution. And this will fail, right? So if I just hit play and go back to my terminal, too few arguments, right? So they could implement dependency resolution here, but I understand why they don't. And I've never wanted it to. I'm just curious. So, all right. So let's get rid of parent service now. So again, it's going to do dependency resolution here, and the way that works is call. So call takes some sort of callback. Any callable, yeah. So it could be a closure, it could be a simple string for a function, or it could be an object. And so what is actually happening when the job is handled, right? So just like for the full context here, when you run dispatch, it creates this new pending dispatch with an instance of the class. And then that gets ultimately put onto the queue. It gets serialized, sent through to Redis or whatever you're using as your queue. The worker will then pick up that serialized version and rehydrate it into the object, which does not call the constructor. It does call sleep and wake up. And I don't know if there's any dependency injection happening there, but I doubt it. I don't think you can. And to be clear, when I say dependency injection happening there, the wake up method is not injectable. It's called by the engine, but inside of the implementation of that wake up method, it could do injection. But I'm not sure why or how even you would do that. That feels odd. It's not really injection at that point. It's just resolution. So it will rehydrate that object, and then it will call the handle method. And when it does that, it is using this thing here. So let's just do new test job. We'll pass in a new user. Why doesn't it like that? Oh, because I probably didn't import it. Yep, there we go. Okay. And so what will happen is it will have rehydrated this, and I'll just hang on. Serialized equals serialize, call our job, unserialized, right? So this send to queue, pick up from queue, and then we're back to here, right? So we take this unserialized job and we call handle, and this here is where we're going to do injection. Now what I'm curious about is when it's a string, which could be a function name, so maybe that's not allowed. Like, it technically is a callable, like it's a valid callable, but maybe they treat those differently. The array of parameters that is passed in, so you can add extra stuff. And then default method, and I don't know what that is. Presumably string could be a class. So let's see here. Push to build stack, false. If class name equals get class for callable. Okay. And not an array. Okay. So oh, interesting. Get the class name for the given callback if one can be determined. I had no idea this was a thing. So presumably this is based on whatever this is. I'm really curious how that works. I'm actually going to try that. So let's just go over here. So class foo public function get closure. Wow, that's annoying. Oh, okay, that's fine. Okay. Oh, right. The serialized stuff is what's causing that, I'm pretty sure. Alright, anyways. Oh, let's actually not call that. Okay, so class foo public function get closure return function. Right, that's that. So I can now do $foo equals new foo, $C equals $foo get closure. So now we have this closure, and what we wanted to look at was inside of call here. This, so we're going to create a reflection function. Interestingly, it's using this is new, right? This is that deferred callback thing. I can't remember exactly what it's called, but all right, let's take a look at that. So $f equals new reflection function $C. Yeah. Okay. And then this should be false. Well, hang on. Okay, that isn't false. Okay, so get closure scope. Oh, okay. Ooh, sorry, I don't know why that happened. So if it is a... Oh. Okay, that's interesting. All right, so hang on. Let's try this now. $f equals new reflection function, and we're going to pass in our foo and get closure. No, hang on. Yeah, I don't know if you can do this. Let's find out. No, okay. Oh, right. New foo. Do I have that already? Yes. Okay, so now it's no longer going to be anonymous, right? That's my expectation. Correct. So now we can call this. I'm curious. That should return foo. Yeah. And specifically the instance of foo, presumably, that we had. I don't know how to verify that. Well, no, it's just a reflection. I don't know. Genuinely don't know if it's the exact one, but I don't think it necessarily matters here because we're just trying to get the name. Okay, so if we are not passing in an anonymous function, which I'm not sure why you necessarily would. I guess you could. Yeah, there's no reason you can't do injection on a closure. Alright, so if it has a class and it's not currently in the build stack, it gets added to the build stack. Okay. And then we do this bound method call, right? So what does this do? If it's a string and there is no default method and the method exists, invoke. Then it goes, okay, so we're doing a callable class, an invocable class. Is called with @? Oh, I didn't know you could do that. Okay, that's a thing. If you didn't catch that, you can pass in like that as a thing you want to call. So that's fine, whatever. Then that will just call class. I don't even want to explore this. I feel like it's awful. Yeah, it just calls call. Okay, so it just kind of, that's kind of what I expected. It just splits apart the string and calls it. All right, so once we've kind of gone through all of that and we have, we know what we're calling, it's going to call the bound method. So if you pass in if you just pass in a function name, right? This is what I'm trying to like distinguish between. It's between a class name where it's invocable, and or you specify the default method, or it's just a string function name, right? So this says if it's a string, but we don't have a default method and it is invocable, right? So we've determined that it is definitely a class name by the time we get through this one. But if it doesn't have invoke, and we didn't pass in a default method, which would also imply that it was a class, it doesn't have an @ in it, then we're going to get into this call bound method, and callback is just a function name. So it has this call bound method, and it's going to run, or it's going to pass in this closure that gets the method dependencies. Let's just dig into this first. So if it's not an array of callbacks. Wait, what? Why would you pass in okay, never mind. Whoa. So it always uses class method for the container. Has method binding, call method binding. Okay, so this is where does this get set? I mean, sure, I expected this to kind of exist. It never gets called? It must. Okay. I don't see that happening. Container. Oh, it's probably happening in here. Because no, yes, I'm guessing that's what's going to happen. So this is like if we're calling it multiple times, right? Is my expectation. Also, it wrapped it, and then it only calls the first one. Not sure what's happening there. but okay. There may be a stack that we're missing. We'll get to that. All right, so let's go back into here. Let's take a look at what's happening here. So it is calling the callback. Again, this is a closure, so it hasn't been called yet, with the array values of the method dependencies. So let's take a look at that. Get call reflector for the callback. All right, so this could be a reflection function or method. Gets the parameters. Add dependency for call parameters. Okay. So if it exists in where? Parameters, which here. Okay, so if we did pass in the thing, then it doesn't try to resolve it, and that's totally fine. Otherwise, get contextual attribute. So I believe that there is a attribute. Yeah, this was added. I think it's fairly new. Otherwise, we get the parameter class name. Where's class name? Where's that? Oh, sorry, it is getting the. Okay. If it exists in the list of parameters, then we just take it from there. If it's variadic, interesting, then we have this whole variadic dependencies, which presumably you only have one, right? Only one parameter can be variadic, which is why there's not like an array of them here. And it will array merge those. And if that's true, that returns an array. What is this? Doesn't it always return an array? Or false, right? Sorry, what was that function called? Why did that not actually take me to array merge? Here we go. Merges elements one array to another and will return an empty array. Yeah. Oh, is there a false? I genuinely don't know. This would, empty array equals false, right? So the turn array would fail. I missed that. All right, it's actually to do with this. Okay, so if it is not an array, is an array already. So if make returns an array, then it won't wrap them again, because we'd end up with nested things. Okay. If there's a default value, because we couldn't resolve it, but there is a default, then we'll take that. If it's not optional and it's not in the parameters, then it couldn't resolve it, which is great. And then it just returns an array merge. And dependencies was an array that was passed in. Because it's this loop, right, of all the parameters. Okay. So that's where all of that resolution is happening, and then ultimately the values are passed in. And the reason that it's doing that is if it had named keys, which I believe it does, it would try to do named arguments, right? Array values just makes them go in positionally. So that's fine. Yeah, so this is where the resolution then happens for that for things like the handle method, right? Now I find it interesting. Like there's actually a lot of like flexibility here. So let's see. So it can be a callable, which I think could just be an object. I don't know why it wouldn't allow that, because you can have an invoke. Yeah, you can have an invoke on that, which makes it callable. I'm not sure why that wouldn't be a thing. And then you could have default method foo, right? Something like that, right? That's doable. This could be test job, right? So it could be that, and it will resolve that automatically, but call foo on it instead of handle, right? I think, though, realistically, internally, it is just doing this, or the equivalent of this. All right. I think that is it. We are over 2 hours. Thank you, everyone who attended. Appreciate your eyeballs and your attention. I know this was long. Obviously getting quite deep into the weeds here. I will end with, it is election day in the United States. Whoever you're voting for, please go out and vote. I've already mailed my vote in last week, so I was able to sit here and do the stream. And hopefully this was a reprieve from those of you who just don't want to pay attention to it. So, thank you so much for your time. Appreciate it much.